Okay, now discuss some problems, numerical problems. Before that, last time I will give one formula to you, and now I am going to give one more formula. So lens makers formula. Lens makers formula. This is not given in your textbook actually, but I will give you 1 by f equal to n minus 1. 1 by f equal to 1 minus 1 into 1 by r1 minus r2. 1 by 1 into right. So 1 by f equal to n minus 1 into 1 by r1 minus 1 by r2. This is the lens makers formula. Here f is equal to focal length, n is equal to refractive index, n is equal to refractive index, r1 is equal to radius of curvature, from one side, one curve. So here r2 is equal to also radius. R2 are the radius of curve, second radius, second curved side, first curved side and second curved side. So R1 and R2 are the radius of curvature, n is the refractive index and f is the focal length. I should not given in your textbook. So but keep in mind this is very useful to you in coming studies, especially use also. And lot of derivation is there about even for the lens formula. 1 by f equal to 1 by v minus 1 by u. 1 by f equal to 1 by v minus 1 by u. There is some derivation is given. But maybe it is very difficult to learn. So that's why the derivation did not give in your textbook. Just directly the formula is given. So in a previous 10th class textbook, there is a derivation for Miller formula, magnification, X formula, lens makers formula, and image formed by spherical surfaces. In case of refraction, all for everything has a derivation, but due to some difficulty, they feel some difficulty to learn. So the derivation is completely eliminated and gives us only the formula. But keep in mind. Right. First problem, let us see. A convex lens of focal length 10 cm is placed at a distance of 12 cm from a wall. How far from the lens should an object placed so as to form its real image on the wall? For example, an object is placed at some distance in front of lens. Imagine that, just a diagram of that. This is a wall and a lens is placed here. So on the table, for example. So a convex lens of focal length 10 cm is placed at a distance of 12 cm from a wall. So here to here is 12 centimeters. 12 centimeters. Next. How far from the lens should be an object be placed so as to form its real image on the wall? So on the wall there is some image is formed. The image is formed on the wall. The distance between the lens and the image is called as the image distance. If the image is formed from the 12 centimeters from the lens, where should we have to place the object? object. So find out the object distance from the lens. In this problem, find the object distance. At which distance, if we place the object in front of a convex lens, the image is formed at 12 centimeters on the wall. 12 centimeters on the wall. Let us calculate. So focal length is given for us. Focal length F is equal to plus 10 centimeters, because for a convex lens focal length is positive. Then what is given? At a distance of 12 centimeters from a wall, where the image is formed at 12 centimeters from the lens. So image distance V is equal to plus 12 centimeters. We already discussed, in case of the lens, in case of convex lens, the image is formed along the direction. So if it is the direction of light rays, the image is formed here. Positive 12 centimeters. Then what we have to find in this problem? Object distance. Object distance U equal. Object distance U is equal to what type of image is formed? Real image. Real image is formed from the lens formula. From the lens formula. So 1 by F equal to 1 by V minus 1 by U. 1 by F equal to 1 by V minus 1 by U. So from this formula, substitute the values. Substitute the values and simplify. So we have to find out 1 by U. U nothing but we have to find out the object distance. So simply 1 by U equal to, we have to write 1 by V minus 1 by F. Simply send this U that side, F this side. Substitute the values. V is 1 by 12 minus 1 by 10. 1 by 12, 1 by 10. Simplification is there. LCM it becomes 16. 12 5s are 6. That is equal to minus 1 by 60. Minus 1 by 60 centimeters. So 1 by U is equal to minus 1 by 60. From this we have to write U is equal to minus 60 centimeters. Minus 60 centimeters. You know, for a convex lens, the image, the object distance is minus. So at 60 centimeters. So if we place the object in front of convex lens at a distance of 60 centimeters, the real image is formed on the wall, which is the distance between the lens and the image is 12 centimeters. 12 centimeters. So we have calculated only one according to the problem. What is object distance? If asked, what is the magnification? If I ask one problem, what is magnification and nature of the image? Magnification and the nature of the image. Along with the object distance, in the problem, if they ask what is the magnification and the nature of the image. Magnification and the nature of the image. So, nature of the image. Okay, let us. Nature of the image real and inverted, as we know. Real and inverted convex lenses form the real and inverted image. So magnification, for example, as magnification magnification m is equal to magnification m is equal to two formulas, height of the image by height of the object and image distance by object distance. So here didn't give anything about the height or size of the image or size of the object and height of the image. So we have this formula m is equal to v by u, m is equal to v by u. So that's equal. Substitute the values, m is equal. What is the image distance? 12. What is the object distance? 6 minus 60. So 12 5s are 12 1 is 12 5s are. So m is equal to minus 1 by 5 minus 1 by 5. That is equal to m is equal to minus 0.2. Minus value is big. Minus value is big. So highly diminished. Real and inverted and diminished images form. Real and inverted and diminished images form. So the value of magnification is less than 1. Is less than 1. So small size images form. Small size images form. And the minus sign for magnification shows that the image is formed below the principal axis. Minus m present, the image is formed below the principal axis. That too, it is less than 1. Less than 1 property is small size image. So what is the nature of the image? Real, inverted, and diminished image. Real and inverted diminished images form. Diminished images form. So in this way, we have to calculate the magnification then according to the problem. Some cases they give the object distance and ask to calculate the image distance. Or sometimes they give both the object distance and image distance and ask what is the focal length. When we know the object distance and image distance by using the formula m is equal to v by u magnification, and also we have to know what is the magnification, real inverted, highly diminished, enlarged. So like that we have to find. This is the first problem. Then let us discuss one more problem. Practice the problems, understand the problem, what the values are given. Right, one more problem we have to discuss. If an object of 7 centimeter height, is placed. 7 centimeter height is placed at a distance of 12 centimeters from a convex lens. Of focal length 8 centimeters. Find the position, nature, and height of the image. Right? So, read the problem. If the object is placed, height of the object is 7 centimeters. At which distance the object is placed in front of the convex mirror? Length of 12 centimeters. And what is the focal length? 8 centimeters. Then find out position at which distance the image is formed. What is the nature of the image? Is it real image or virtual image, enlarged image, diminished image, and height of the image. At which height it is formed. So let us find. Let's write the given values. Given height of object, height of the object h1 underscore or we have to take ho, no problem, is equal to 7 centimeters. Focal length minus 7. Focal length f is equal to plus 8 centimeters. Plus 8 centimeters. Then what we have to find next term? Image distance. Image distance v is equal to then height of the image. Height of the image hi or h2 equal to then nature of the image. Is it real image or virtual image is formed or not? Object distance is, sir, one more thing I have forgotten. Object distance. Object distance u equal to minus 12 centimeters. If the height 7 centimeters only, not minus. Right. So from the formula 1 by f equal to 1 by v minus 1 by u. 1 by f equal to 1 by v minus 1 by u. So we know f value, we know u value, we have to calculate the v. We have to calculate v. So let us solve. Substitute the values first of all. So 1 by focal length is 8. That is equal to 1 by v. We have to calculate minus of object distance is 12 minus 12. So write 1 by 8 is equal to 1 by v plus 1 by 12. Substitute this. So 1 by v is equal to 1 by v is equal to, now write 1 by 8 minus 1 by 12. 1 by 8 minus 1 by 12. So simplify it. So 1 by v is equal to LCM. If you take LCM, this will become 24. 24. 8 3s are then 2. So 1 by v is equal to 1 by 24. 1 by v is equal to 1 by 24. So v is equal to 24 centimeters. So at which distance or at which position the object is formed? So 24 centimeters from the lens. 24 centimeters from the lens is formed. So image distance. Image distance or position. So image is formed at form 24 centimeters. The position of the image is 24 centimeters from the lens. Okay, we have calculated the position. Then find out the height of the image. Height of the image. To calculate the height of the image, first of all measure the magnification. Magnification m is equal to two formulas of height of the image by height of the object. If we use that formula m is equal to height of the image by height of the object, we know only height of the object, we don't know magnification. So from this form, instead of that, use m is equal to u by u. M is equal to v by u. Substitute the values. Object distance 12 centimeters, image distance image distance 24 centimeters. So 24 by minus 12. 24 by minus 12. That is equal. M is equal to minus 2. M is equal to minus 2. So this minus represent the image is formed below the principal axis. and 2 is more than 1. Magnification. So m is greater than 1. M is greater than 1. So enlarged image is formed. Enlarged image is formed. Enlarged image is formed. So magnification is more than 1. Magnification is more than 1. So enlarged image is formed. And in each case we have got the enlarged image. So if the image is virtual. So in case of virtual and erect image, magnification is more than 1, and this minus is represents forms below or above, larger than the image. So the value of magnification is more than 1, so the image is larger than the object or magnified. So not virtual, sorry. Let us do the problem. So some case it forms the larger than image. When it is larger than image is formed in case of convex lens. In which case it forms the larger than image when it is placed in between. It is placed in between F and 2F. The object placed between F and 2F, it forms the enlarged image. So the enlarged image is formed. Now we know magnification, we know height of the object, then position. So height of the image from magnification m is equal to hi by h2. From this hi is equal to m into h2. Magnification is minus 2 and height of the object is 7. So height of the image is equal to minus 40 centimeters. Height of the image is equal to minus 40 centimeters. So magnification as minus, so it forms the below the principal axis. Below the principal axis. So below the principal axis, then what type of image is formed? Real and inverted. Real, inverted and enlarged image is formed. So finally, at each position and at each distance, the image is formed 24 centimeters from the lens. What is the nature of the image? Real and inverted enlarged image. Because magnification has minus symbol, that minus sign represents the image is formed below the principal axis. And magnification has value 2, it is more than 1. If the image has magnification more than 1, the image is enlarged image. If the magnification is plus, if the magnification is plus, then the image is formed above the principal axis. So above the principal axis is a virtual image. Virtual image. In this way, you have to calculate the given values. These two problems are regarding to the convex lens. Convex lens. Then let us discuss one or two problems regarding to concave lens. Regarding to concave lens. Regarding to concave lens, let us take a simple one more example problem. If the magnification is produced, if the magnification m is equal to plus 2.5, what is the nature of the image? Just now we discussed, if the magnification has positive sign, it forms above the principal axis. So what is the nature above the principal axis form in case of convex lens? It is a virtual image. What is the nature of the image? Virtual and enlarged image. Then nature of lens. Nature of lens. Magnification is more than one, so the image is larger than the object. A virtual erect and magnified image is formed when convex lens. Convex lens. In case of concave lens, magnification has positive sign, no problem. Magnification has positive signs, no problem. But it forms the image, the diminished image. The magnification value is less than 1. Less than 1 with positive sign. When in case of concave lens. In case of convex lens, magnification sign is positive, but magnification is more than 1. So keep it. Problems regarding to convex concave lens. Numerical problems. Let us take the first problem. An object is placed at a distance of 50 centimeter from a concave lens. Sometimes didn't mention the type of lens, simply given diverging lens or converging lens. Concave lens of a focal length 20 centimeter. Find the nature and position of image An object is placed at a distance of 50 centimeter from a concave lens of a focal length 20 centimeter. Find the nature and position of an image. Here we have taken the problem given concave lens. Object distance is negative for all, either it is a concave or convex, no problem. Image distance for concave lens. Image distance for concave lens is positive or negative. Before I gave a sign, Taylor form is given. Image distance is negative or positive for concave lens. Negative, because it is opposite to the direction. Okay, left side. So let us solve the problem. Object distance u is equal to minus 50 centimeters, because it is the left side of the lens. In case of sine curve, we discussed that object always places the left side of the mirror or lens. Then focal length f equal to minus 20 centimeter. Focal length is minus 20 centimeters. It is a concave lens. For a concave lens, focal length is negative. Then what about the image distance? V is equal to, we have to calculate the image distance. Formula 1 by f equal to 1 by v minus 1 by u. 1 by f equal to 1 by v minus 1 by u. So 1 by f, 1 by v is equal to, set this value aside, 1 by f plus 1 by u. 1 by v is equal to 1 by f plus 1 by u. Substitute the values. 1 by v. Focal length minus 20. So minus 1 by 20 minus 1 by 50. Because for a concave lens, object distance, image distance, focal length all are the negative. So simplify it. Then LCM 100. 100. So 25 that 5 up to 50s. That is equal to 1 by v. 1 by v is equal to minus 7 by 100. Minus 7 by 100. From this 1 by v is v is equal to reciprocal. So v is equal to 100 by 7. So divide the 100 with 7. 7 1 that 7. V 0. 7 4 that 28. 7 4 that 28 2.0. 7 2 that 14 6. So approximately 14 point something. Approximately we get 14 point to something. So V is equal to minus 14.60 and 7 5 35 7 8 are 56. So 14.28 centimeters. So object distance or the position of the image. Object distance or position of the image is minus 14.28. Approximately we have taken minus 14.3 centimeters. This is at which distance the image is formed from minus at distance from 14.3 centimeters. So thus the image is formed at the 14 centimeters of concave lens. The minus sign for the image distance shows that the image is formed on the left side. The image is formed on the left side of the concave lens. We know concave lens has forms virtual and erect image. Always we know that what is the nature of the image. Nature of the image formed by a concave lens is virtual and erect. Virtual and erect. Then what about, can we calculate the magnification for this problem? If I ask you, for example, ask magnification aspect. So virtual and erect image is formed. Then what about the magnification? If the problem has find out the magnification. Magnification m is equal to height of the image by height of the object, that is equal to v by u. That is equal to v by u. So you can come to notice m is equal to v by u. That's equal to image distance how much? Minus 14.3. Minus 14.3 by what is the object distance? Minus 50. Minus get cancelled. So m is equal to plus. So approximately take 14 on. Approximately take 14 by 50. 14 by 50. 7 14 250. So 725. So 0.0 25 2 jar 50 2020. We place 0 here, approximately 8. So 0 plus 2, 0.28. 0.28. So plus represents magnification is positive because in case of a concave lens, the image is virtual and erect. So virtual and erect images are always from above the principal axis. So it is a positive. So it is less than 1. So diminished image is formed. So this is about one problem regarding to concave lens. Concave lens. For example, one more problem. The magnification produced by spherical lens is plus 0.7. Magnification m is equal to plus 0.75. 0.75. What is the nature of the image? Virtual and erect. Virtual and erect. Less than 1 and diminished image. Less than 1 is diminished image. So which lens forms always the diminished, virtual, erect, and its magnification is positive? Concave lens. Concave lens. Let's take the one more problem and start. One more problem. An object placed at 15 centimeter. An object placed at 50 centimeter from a lens produces virtual image at a distance of 10 centimeter. At a distance of 10 centimeter in front of the lens. Draw a diagram to show. Draw a diagram to show the formation of image. To show the formation of an image. Calculate focal length and magnification. Calculate focal length and magnification. Here draw the diagram also. Here asked to draw the diagram. దీనికి సంబంధించి మనం డయాగ్రామ్ కూడా డ్రా చేయాలి. సో diagram also. Read the problem. An object placed at 50 cm from the lens produces the virtual image at distance of 10 cm in front of the lens. Draw a diagram to show the formation of an image. Calculate the focal length and magnification. So let us write the given values first. Solution. Object distance u is equal to minus 50 centimeter always. Then image distance b is equal to also minus 10 centimeters. Then what we have to find? Focal length f is equal to then magnification, and also given draw a ray diagram. Let us first find out the focal. Let us find the focal length of the object, focal length of the image. So formula 1 by f equal to 1 by v minus 1 by u. 1 by v minus 1 by. Substitute the values. 1 by object minus 10 minus of minus 50 minus of minus 50. ఇది కాన్సెప్ట్ కాబట్టి 1 by f equal to minus 1 by 10 plus 1 by 50. 1 by 50. So LCM 50, 5 will be minus 5 plus 1. So 1 by f equal to minus 4 by 50. Minus 4 by 50. So from this reciprocal also f equal to minus 50 by 4. Minus 50 by 4. By simplification we get f equal to minus 12.5 centimeter. Minus 12.5 centimeter. Focal length is minus 12.5 centimeter. Object distance, image distance is minus 10 centimeters. Object distance is 50 centimeters. From this we have to draw the ray diagram. Ray diagram. So convex, concave lens, principal axis, optic center C. Optic center C. So for example, here it is the focus. Here it is the focus and here it is the focus. Here to here. Distance between focus and the optic center is called as focal length. Distance between optic center and the focus is called as the focal length. So distance is how much? Personally calculated 12.5 centimeters. Focal length is 12.5 centimeters. Where the image is formed at the 10 centimeters. So approximately 12 and here the image is formed. Here the image is formed. Where the object is placed 50 centimeters. So 12 into 12, 24, somewhere, for example, the object is placed somewhere. It's the 2f. Here, for example, here the 2f. Here the 2f. So object placed here. So here to here is 50 centimeters and here to here object distance 10 centimeters. Here to here focal length. So idemo image distance, idemo object distance, ఇది వచ్చేసి focal length. Object ఇలా. So parallel rays ఇలా వస్తాయి. Then the image forms like this. So one more thing, graph diagrams. So here the image is formed. This is the ray diagram. This is the ray diagram. So know the what is the focal length? Focal length is the length between the optic center and the focus. Optic center and the focus. When you know the focal length, we know very well. In case of concave lens, the object always formed in between the focus and the optic center. In between the optic center. So, image distance always less than focal length. This is right. Then magnification. Magnification m is equal to 3 by. So, object distance minus 10, object distance minus 50. So m is equal to 1 by 50, 1.15. So m is equal to plus 0.2. Magnification m is equal to plus 0.2. So plus represents image is formed above the principal axis. So 0.2. 0.2 is less than 1. Less than 1. If it is the less than 1, it is a small size image. It is a small size image. Image. If it is equal to 1, magnification is equal to 1, same size of image. If the magnification is more than 1, enlarge the image is first. If the magnification is less than 1, the magnification is less than 1, diminish the image. If the magnification has plus sign above the principal axis, if the magnification has minus sign below the principal axis. So keep in mind all those things. Practice your own problems by changing the values. And there is only one topic is left, that is power of lengths. Power of lengths. So later we have to discuss power of lengths. Power of lengths. And regarding power of length, there are some simple problems. So follow the classes regularly. Share the channel with your friends. Like the video. Give me a comment. So this is my request. So thank you so much. That's all for this session.